Okay, I think we can start with the presentation. So thank you everybody who were able to join this webinar. So the objective of the webinar is to present the results what we did under the Digital Square Notice E0 project, which is called openIMIS Shelf Readiness. So I will do the presentation, and then my colleagues who work with me within this project from Swiss TPH and from Soldevero, so Patrick, Severin, and other colleagues, developers from Soldevero, will complete me or answer to questions. So the presentation will be more extended on the FHIR module. So FHIR concept, what is FHIR, what we did with the FHIR module, and then small feedback of what we actually developed under the E0 project for the packaging and for the developers tools. So the project description. So we started the project on 8th of April 2021 with a deadline on end of December last year. So the parties were, so the project was managed by Digital Square, which is under PATH. If I understood correctly, it's funded by Bill and Melinda Gates Foundation. And on the actual work to be done by Swiss TPH, Soldevero, and Blue Square, which Eric is also here. So there were 4 work packages that were proposed, and for the 4 only 2 were community engagement. So we engaged with the openHIE DevOps community for all the packaging and openHIE and openHIE scripts installation, and with openIMIS community, of course, with all the elements of the FHIR module and the developers tools. The project output. So as an output, we have the new version of the FHIR 4 module for openIMIS, the improved openIMIS Docker package, which includes also an instant openHIE script and some openIMIS developers tools. So I will start first with openIMIS FHIR module. So it would be more generic to the specificity of what we did. So why an interoperability layer for openIMIS? Why we need the FHIR module? So an example of integration. So we have an insurer, you have an health facility, and then you have a patient. So in order for the patient to receive free medical services, we need to have an insurance. So getting enrolled with an insurer. Then go to the hospital, get registered. The health facility will check the insurance enrollment to see if the patient has to pay something or nothing. Once that is checked, required to get health care from the hospital facility, and then health facility submit claims to the insurer. So here we see a clear example where there is an interaction between health facility and the insurance. And currently, before having any integration, so there are different applications that will be used for openMRS for the hospital management system management, and openIMIS for the insurance. So the whole facility will have to use different systems, different applications in order to submit and register data. So this brings us some problems. We'll see next. Why we need an interoperability layer? So to improve productivity and quality of operations. So minimize data entry error risk. So actually, when you have to enter the same data in multiple applications, there is a risk that the human operator will introduce wrong data, because usually it's a copy paste. If you don't press the right buttons, you will paste the wrong data. So having only one entry source will limit actually the error risk, but also reduce operational cost, because the time spent into using multiple applications will be reduced to only one application. Will ease, in our case for openIMIS, will ease claim submission, because this claim will be automatically transformed and sent between the systems. And for example, reduce claim review and payment delays, because the claims will be immediately received in case of services registered, the claim automatically created and sent, and can be also done automatic payment requests from openIMIS to payment systems through FHIR. Another reason is to optimize openIMIS for social protection data and processes. So there is the idea of one source of truth. openIMIS actually now is managing every data, master data, what we call the data related to the well facilities, to the medical item and services, to other information on employees. So if we have that dedicated register outside of IMIS, like for facility registry, then we can only keep openIMIS managing the social protection data and processes. And also the source will be always up to date between different systems. And integrated system, we need to make sure the data between the two systems. For example, one service created in the hospital management system needs to be the same service, I apply CD10, which will be submitted to openIMIS 2. So the semantics and syntactics have to be recognized between the two systems and to have the same meaning as the code. So another business processes are managed externally. So openIMIS is a social protection management system. So it's not an accounting system, for example. It's not a payment system. So all the specialized system should be managed outside and manage processes outside and keep openIMIS only to manage social protection processes. Now, what is FHIR? So FHIR is a standard for information representation, so to display the information in a specific way and to electronically exchange the information on health services. So it's based on health domain, and it's based on modern web technology. So it's specified by Health Level 7, so which is an organization who specifies standards in health domain interoperability. And there are different versions. So the first version was released in 2014. The version we used during the project, so last year, is the FHIR version, FHIR 4, which is called, so release 4, which is version 401, which was released in 2019. There is, in the meantime, this year in April, 28th of May, excuse me. So there was a new version released, FHIR R2B, which is 430. So this is now the official version. So we have to be discussed with the openIMIS community to which extent we need to check and update the new version. And there is also a new version which is under discussion, FHIR R5, which has a snapshot release 500 in December 2021. So what FHIR is coming to, and you know, you say it's FHIR, but it's not actually FHIR. Even the logo is a FHIR. So FHIR. So F for FHIR is fast. It's for fast to conceive and operate. Arcade is the business domain. Interoperability is what interests us. So to exchange data between systems, to interconnect systems, and resources. So fast and arcade resources actually the basic data sources. So this is the basic object that is exchanged between systems during interoperability. So now what is a resource? So a resource defines the data structure. So as you can see here in this diagram, so the data structure is what is inside the claim, the identifier, a status, a patient, a provider, a total amount of money. That's the data structure. There is a data constraint. So for example, we need to provide a patient. So you see the patient in the claim, it's multiplicity of cardinality of 1 to 1, which means you must provide a patient every time you create a claim. A provider, but you don't need to, you need to provide the total amount of the claim or not. It's not mandatory. And there is a data relations. So meaning a claim is linked to a patient. A claim is linked to a practitioner. So all this information is to be defined as a resource. And then we have the profile. So the profile is actually a personalized resource. So it's a derivation of FHIR resource. So it could be a generic one from the FHIR profile, or can be a derivation for another profile. So for example, you have the openIMIS profile, and then you can define another profile starting from the openIMIS profile. And you can do that by extension, so you can add additional information and fields that doesn't exist in the original profile, and or by the restrictions, meaning, for example, in the claim, you need to provide a total amount of money every time, so a mandatory field, so meaning you put cardinality of 1 to 1. Another object in FHIR, so the code system and value set. So a code system defines the codes which exist and how they are understood. So this is the meaningful information when you exchange resources between systems, as I mentioned just before. So when you want to send the medical service from a hospital management system to openIMIS, they need to be the same coding defined to be understood by the both systems. Examples, so there's NOMAD, CT, LOINIC, RX norm, ICD family. So usually openIMIS is working well with ICD family. And then a value set is actually a group of codes of multiple code from one or multiple code systems, so can combine codes from multiple code systems. So for example, you can have some codes from ICD, some codes from NOMAD, and then that is to be used in specific context. So in a specific implementation, for example, of openIMIS, you don't need the full amount of ICD codes because, for example, it's only managing using openIMIS to manage reimbursement cost of HIV services or malaria services, and then you only restrict the ICD families, ICD codes to those codes specific to the specific context. Now, one example of resource. So this is a patient resource. You have the type, you have the identifier, and some metadata to specify which profile it is, ID Joe Doe. There is human readable information that can be displayed, so which is displayed on the website, for example, and understandable, readable by a human person. There are extensions. For example, if the patient is ahead, it's a Boolean value. If there is a group to a reference to a group, for example, which family the patient is part of. And then is the standard data, which contain different values here. And as an example, identifiers, which is, for example, the insurance code, the name of the patient, family name, given names, gender, birthday, and there are lots of other information to be added fields. The FHIR implementation guide. So the FHIR implementation guide actually is the profile documentation. So when you want to define a profile, you define an implementation guide to display how the changes, what are the changes from the original profile are, and how to use actually that profile. So as default information, you will see the personalized resources, the resource structure as we saw before. Here, the patient, for example, you see the list of possible interoperability operations. So if you use that profile with the API, specific API, you can read one resource, search for them, create a new one, update, delete. All these operations can be done based on HTTP operations. And there are other information that can be listed, which is, for example, security. What are the security authentication mechanisms, authorization mechanisms that need to be used? Integration workflows, for example, how you can integrate with the system and which workflows you can use. Now, moving to openHIE. So the project was a part also of openHIE community and architecture. So openHIE is coming from Open Health Information Exchange. There is an architecture defined, and with the architecture there are different standards as interoperability in the health domain. So it's a community of practice defining all these standards, and those specific data interoperability standards for health are defined between open source projects to exchange information between them. So in finance and insurance services, one of the new entry into this architecture where openIMIS is representing this service. There is different communities within the openHIE community of practice. So there is health financing toward USAC community, where Uwe and me were discussing with other members on workflows, interoperability, activities in order to provide workflows and different services in the interoperability with finance and insurance services. There is a link, so you receive the presentation after, where you can see the full openIMIS architecture documentation there. As an example, claim submission workflow, which was developed under the FHIR Financing Tower USC working group. So there is a claiming workflow here. On the right, you can see different steps between the point of services, the interoperability layer, and the financial information system there. And on the left in the table, you see, for example, the different FHIR resources that could be used and to be used actually during this interoperability workflow in integration. Now, the achievements. So from the project, what we actually achieved. So the objective was to allow openIMIS to integrate with the external system in a standardized way, and in the same time use the existing interoperability standard already used by other systems. So once go with another one, so we decide to integrate to FHIR, which is used by external system, and also it's a standard so to allow external system to develop their FHIR integration for openIMIS. A brief history of the FHIR module. So in 2019, so most of the beginning, starting with the FHIR module, were digital square projects from 2019. So we started in 2019 with the FHIR S2.3, so version 3 of FHIR for the integration with openMRS, BAHMI, and DHS2. So here also developers were helped Spina worked on this project, leads those projects. In 2020, we worked on the FHIR 4 integration, so to shift to version 3 to version 4 because we needed new resources which were not part of the version 3 for the claim AI project, and then was also used by the DHS2 integration version 2 later on in same year. So in 2021, we have the openIMIS Shelf Readiness project, where we actually improved a lot the FHIR module. And in 2022, we continue working on this through the Claim AI version 2 project, payment layer, and of course, GovTrack integration. How we did that? So the mapping, first of all, we started to work on the mapping between openIMIS and FHIR. So before, in the first versions, in version 3 in 2019, we started doing the mapping in openIMIS wiki. So as you can see on the left, we did tables with different resources, remember claim response, coverage, linked to the which tables, notes, statuses, and then for each of the resources, we have specific wiki page to say, again, in a table, for each field, what is to be mapped from openIMIS. So identifier, for example, claim ID, UID, and code, the patient, the billable period. So all this was done manually. Also being done manually, the conformity of the standard was validated manually. So which actually brought us in observation later on that the actual generic profile from FHIR was not fully satisfied. So this is why in actually openIMIS Shelf Readiness, we're starting to use the specific tools to do the mapping and the building of the implementation guide. So we used what is called the shorthand, FHIR shorthand. So it's a tool actually to starting from fish files, FHIR files, in which you define your profiles, generating to their tools and implementation guide publisher, IG publisher. There is giving you the implementation guide, which is seen as the menu, as I mentioned, as a documentation on how to use the profile. So I will not enter into detail to explain this image here. So it is coming from FHIR shorthand, this process, but to use this process actually and now we are using this process to build the openIMIS FHIR implementation guide, meaning the documentation. So as achievements, we define lots of profiles. So here we have the FHIR resource, which is mapped to which openIMIS entities and the statuses. So the statuses you see updated new is basically what is the difference from the previous version before the openIMIS Shelf Readiness project. So most of them were updated. There are new profiles like organization. So the facility were mapped to an organization, policyholder organization. So you can see you also have an openIMIS entity mapped to the same resource. There is also a policy which mapped to multiples. Enrollment officer, career administrators. This is because we need to actually have the same. You only find one resource can match different entities, and there are also some of the new profiles here up to insurance plan mapped to the product, which was not there. It was not before. But we also put here in the table, as you can see, invoice and bills, payment notice, subscription. All these were developed later on under the payment layer project. But I prefer to add it into this for everybody to see which are the available resources under the openIMIS FHIR profile. We also deleted some of the initially created profiles, for example, conditions, which was mapped to diagnosis. Well, why we removed that is because in the condition resource in FHIR, there is a mandatory field, which is a patient. And in our case for openIMIS, the diagnosis was a default list of diagnosis without linked actually to any condition, any injury actually. So this is why we removed that, and actually we shift diagnosis actually to a code system. So now Patrick wants to add something. Please.
Yeah. So in FHIR 5, R5 that is under development, they actually create a definition of diagnostics that might be used in the future, but that will be for another time. So FHIR recognized that they were missing this kind of diagnostic definition.
So because of that, in FHIR 4, we define the diagnosis as a code system. So a code system, as I mentioned, is define a list of codes that can be used within the profile. So here we define different code systems. So diagnosis is one of them, but there are also all the what we call the option list that are used in openIMIS. For example, to create a patient, we need to define education level, profession, the relationship for the one of the insured to the head of the family, the group types with the family types, different legal forms for facility and policy holders, so all these code systems. And you can see on the left how they are used. Every time you define, for example, an instance of a resource, here in the case of John Doe patient, you will see the patient education is university, patient professional is an employee, and patient education type, for example, is a national ID, which is used. The output of the implementation guide for openIMIS. So you will see in the implementation guide, the link is fhir.openimis.org, which can be accessed at any moment. So we will see the available resources mapped as you saw in the list before. The resource structures, you see here on the right, the patient profile for openIMIS, where you have the different default values, but also a list of extensions. The patient is head, education level, profession. You can see also slices. So some of the fields are slicing, meaning you define one field, one attribute can have different values based on a code. So here an identifier can be insuree code, so insuree number, or can be an UID, so a database identifier. We also added actually a new authentication and authorization, so it was not part of the FHIR module before this project. So we developed the same authentication mechanism as in the new modular openIMIS. And actually it's almost the same as is used also in the legacy REST API. So there is a new login endpoint to receive the token, and actually every time you request a new a resource or a list of resources from the other endpoints, you will have to submit the JOT token through the bearer authentication header. Then we added also the FHIR authorization mechanism based on user roles and attached authorities. It was not the case before. And also we made sure that the location is taken in consideration when accessing to the data. So in openIMIS, as you might know, the authorization is based on user roles, which is a group of authorities, permissions, but also on location of the user has the right to access data. So we also make sure that the FHIR module also use the same authorization mechanism. And this is why we take the query set from the business module. So it's if in the normal openIMIS something change on this, will automatically be impacted on FHIR module. So in the openIMIS FHIR implementation guide, we also define the free workflows. So there is an enrollment, the inquiring, and claiming. So for example, the enrollment here, so it's a continuous workflow. I split it in two because of the slide size, but it's a continuous workflow. So there is two steps. The master data synchronization, where the different code systems are retrieved, but also the sum of the resources, for example, location, insurance plan, or the products, practitioner, enrollment officer, the enrollment officers actually which enroll them. So all this information need to be synchronized beforehand, so at least before doing an actual enrollment. And then the second step will be the enrollment data synchronization. So the actual enrollment activity will happen on the external system, as is done currently on the mobile app, policy mobile app. And then there is only the enrollment data synchronization, where the different resources, as from the insuree, member of the families, the patient in case of FHIR, the group, which is the family, and the policy, actually are synchronized. One point for the policy here, in the case of FHIR, we use the contract resource, which will also be shared by the formal sector. So here, in this case, it's the informal sector, but we also have the formal sector enrollment. So the contract matches both cases. And why you use the contract is because a contract in FHIR allow us to group the family, the patients, so the main head of the family, the beneficiary, and the dependents, the actually insurance product, which is to be enrolled to, and also a contribution of premium that can be added to the contract. So this is why you use this contract, and not actually because policy will be one-to-one matching coverage resource in FHIR. So here we don't have the coverage, but when you want to retrieve a policy, you will get a coverage. What you want to submit to create a new policy, we'll have to submit a contract. As you can see here, internally to openIMIS, it's creating the policy and attach the policy to the insurees. So this is why we need to have the list of insurees within the resource. Inquiring, the same, master data synchronization information research. Here actually you have the possibility to search for one service or item. The resources coverage eligibility request and coverage eligibility response as a response. And then you have the claiming, which have actually 3 steps. So there is first master data synchronization, where we get the list of diagnosis as code system. We get the list of activity definition medication. Activity definition is mapped to medical service, and the medication is mapped to the medical items, the claim administrator, and the health facilities. You need a list of those resources. Then every time you need to do, so later on, when you need to do actually submit a claim, first you inquire for the patient coverage, because actually in claim, there is one field which is mandatory and is represented by the coverage. So it will the policy to be used, even if you know openIMIS that is not used, because the openIMIS is automatically manage which policy to be used for a specific claim. In case of FHIR, this information is mandatory, so this is why there is a mandatory request to get the patient coverage, so inquire workflow, which I showed it just before this one. And this, of course, claim data synchronization, claim which is automatically generated on the external system and then synchronized with openIMIS. So in FHIR, there is 2 resources for claim. So it's a claim resource to submit a claim, and it's a claim response to have the feedback and the adjudication response after the review of the claim, of the treatment of the claim. Now, our resources available for the FHIR module. So here a list of resources. You have the implementation guide, the last build. So I show you the FHIR.openimis.org. This is which is linked actually to GitHub pages. So the implementation guide is automatically built when new information is submitted to GitHub. And actually, this is the link to the GitHub pages, which is linked also to the FHIR.openimis.org. So you can access either of them. Then there is a GitHub OpenIMIS FHIR for implementation guide, the source, the code source, like in the FHIR shorthand of files. GitHub OpenIMIS FHIR R4 module, the source of the module there. And then you have different tools, the Swiss TPH publisher, which were used, and the FHIR library we used actually to the Python backend module for FHIR. So mention this one because beforehand there was every resources were handmade as a structure. During this project, actually we use this library FHIR resources, which add additional validation on resources. Now some interoperability example quickly. So apart the default one, with OpenHIM, openMRS, BACMI, which were developed in 2019. So I took this graphic from Uwe, and I thank him for it. There is some options between openIMIS under openHIE, as you can see through OpenHIM, DHIS2, BACMI, openMRS. There are some work done under the payment layer project with interoperability with Mojaloop, and there are some candidates that openIMIS can connect to, OpenCRDS, Mozip, SOMAS. So there are some options of the interoperability currently available or to be developed in the future. An example is AI-based claim adjudication, so the module integration of the claim AI. So here you have the actual process of using artificial intelligence engine. So normally you have only rule engine and manual review. By adding the AI engine, actually the manual review is transformed to manual quality assurance. So the medical doctors will not lose their job, but will actually approve what artificial intelligence engine will submit as feedback, but also to give human readable justification to the decision that is provided by the AI model. If we go under the AI engine, so what is happening inside? So there is, it receives actually a FHIR-R4 claim as an input data model, which is transformed to an AI input model, which is specific to the AI model, and then those AI model is executed, and as the output will be FHIR-R4 claim response. So we did this AI module to be generic in order to be interoperable and interconnected with other systems than openIMIS. So this is why we decided to use the FHIR-R4 standard, and this is how actually it's used. One additional input is that the FHIR contained resources are required for references. So this is the name. When you send one of the resource, for example, and it makes references to another resources which doesn't exist on your system, you need to provide them additionally. So if you send the claim, which, as I mentioned before, is linked to a patient, and you don't have the patient in your system, then you need to provide the patient information details also within attached to the same synchronization with the claim. As the architecture, so as you can see, you have an implementation of the Claim AI module in the middle. You have an implementation of openIMIS or any other insurance management system, and the actual link is done through FHIR claim, and FHIR claim response. And for that, you need to develop, for example, interoperability layer for the Claim AI module. In our case, with what we call the Claim AI quality module, which send the data and retrieve the data to the Claim AI implementation. Another example of integration, so with the payment system integration, what it was used actually in the payment layer project. So within this project, we added actually additional profiles. So 4 additional profiles: invoice, resource from FHIR, which is mapped to invoice and bill in openIMIS, payment notice, and subscription. So one important information is about subscription. By registering to subscription, actually, external system can receive notification on new patients, facilities, and invoices. So this is an important aspect for the integration of external systems. Now, openIMIS Docker package. The second work we did, so output. Patrick, to continue with this.
Was the Docker package improvement. So now it has been a long time since we delivered it. So it's fully part of the standard package we have, but we have to remember that it was developed in that call. So we have this Docker, and also it's almost a similar Docker but tweaked a bit and with additional file to be compatible with instant openHIE. So what is instant openHIE? It's basically a script that is the deployment of 8 openHIE member systems. And so now you can use it to deploy openIMIS like that. So you just have to select that you want to deploy openIMIS and then say deploy, and then it will be deployed. So there is a new release that was published today for that to be compatible with the latest release we have, so 1.4, release of April, and that was done by several persons, combination of several persons. And also, of course, in collaboration with Gembi to make the package, and most importantly, that it should be compatible with the software. So there is a small piece of software to deploy the open instant chain. And that's it. I won't go into much detail about the Docker, but if there is question, I will be happy to answer.
Thank you, Patrick. The last output is the developers tools. So the objective was to easy setting up the local backend and frontend with modules for developers to start working on modules, to create backend modules and front-end modules initialization, meaning what the necessary file skeletons in order for developers to just doing the actual development work and not spend time to find the necessary resource in order to have a basic module for openIMIS. As achievements, so we have two group of tools, so with the backend developer tools and front-end developer tools. Backend is much more evolved, much more commands than the front-end. So as you can see here, the list, create backend module skeleton, add GitHub files for the workflows, so GitHub actions, Git ignores, to fetch a module from GitHub and install it locally. So if you want to modify a module of openIMIS, you just need one command to do that, or to get all the modules and install them on local repositories, directories. Then to install modules from PyPy or all of them, and also to create calculation backend module skeleton in single command. So we have two types of backend modules. So we have the standard one, default, and then a calculation rule type of backend modules. And then for the front-end developers tools, we have the download from the repositories and to build it locally. So if you want to work locally on the existing module, to create a new module, and also to add different files as the GitHub actions for specific modules, and fetch modules and install them from local directories. So these are all the tools we developed and are part of the assemblies from the backend and front-end assembly repositories. So thank you very much for being with us today. And if you have any questions, we will be glad to answer to them.